Data frames and series will have built-in attributes and methods that we can call on each of them to perform certain calculations or get specific info. How I determine the difference between an attribute and a method is methods typically have parentheses after them, while attributes are single words. In other words, a method is really like a function, but it is implicitly passed for the object, which means we don't always need to have parameters or arguments in it. Attributes find a value stored in the object's instance dictionary or find something from the object's class. We will be working with a lot of attributes and methods throughout this project, and the more you work with them, the more familiar you will become. First, we can look at two quick examples. So if we read in some of our player data into a data frame with the read CSV method, which we'll go into at more length at a later time, we can begin to call an attribute on the data frame. An example of an attribute would be calling the shape of the data frame. So to call an attribute, we use dot notation, so df, and we call the shape. And if we run it, we see there are 10,633 rows and 21 columns in our data frame. Another example of an attribute would be calling dtypes, which gives us the data types for each of the columns in the data frame. So again, we could write df.dtypes, and since it's an attribute, we don't need any parentheses. And here we see all the different types of data within our data frame. So the player ID is an integer, the season ID is an object, the games played, and all of the other stat columns are all float numbers. And overall, the data frame is an object. Attributes return information about the object. They do not modify an object, all they do is view it, compared to methods which do manipulate or operate or calculate a data frame. To access attributes, we simply add the dot to the object we are referencing, but do not need to add parentheses. With methods, we do need to add the parentheses. An example for when we may want to use a method is when we want to get more info on the data. If our data frame is large, as we saw above, 10,633 rows, then there is going to be no use printing the entire thing. If we do, our Jupyter Notebook will cut it off anyways. It can, however, be helpful to get a few rows to get a better idea of the data we are dealing with. A common approach is to use Pandas' head and tail method. The head gives us the first 5 rows of the table by default, while the tail gives us the last 5 rows by default. To call it, we use a dot notation and call the name of the method on the data frame. So again, if we have our df data frame, we can call the head method, and it's a method, so we have the parentheses, and if we run it, now we are going to see the first 5 rows of data from the data frame. Now again, we have 21 columns, so it's not going to be able to print all 21 columns, which is why you see the ... here. But the head by default returns 5 rows. What's interesting is that because it's a method, it is actually saving this data to a brand new data frame. This means we could save it to another variable, and we would have a new data frame with just 5 rows of player data. So if we actually went in here and saved it as df5 rows and ran it again, and now we printed df5 row, we get an entirely new data frame. We can also call the tail method on our original data frame, and this will give us the last 5 rows of the data frame. So basically what's happening here for both the head and the tail method is we are passing in an optional n argument that allows us to choose the amount of rows to show. So if, for example, we wanted to get the first 10 rows of a data frame, we could write 10 in here, and now we have 10 rows. If we wanted to look at the last 7 rows of the data frame, we could write df.tail, and in the n parameter, add in the 7, run that, and here we now have the last 7 rows of the data frame. Another method I use a lot to get a sense of the data is the sample method. This returns random rows depending on the number you pass it. I find it useful in case the data is grouped closely together when you won't be able to tell if something is wrong when looking at just the first few rows or last few rows of data. So if I wanted a random sample of data, I could write df.sample, and it takes that same argument. So let's take 12 sample rows. And again, you'll see kind of the season IDs are all different this time since it's just taking samples out of those 10,000 plus rows. Other common methods for getting basic info in a data frame are the info and describe method. dfinfo gives us information about the index, data types, and memory of the data frame. This can be helpful if you run into any errors or bugs with a certain column being the wrong type of data type. So again, we see a lot of information, the total number of rows, that it's non-null, and the different type of data type object. Similarly, df.describe gives us summary statistics for numerical columns. So if we had our stats for the entire year and we wanted to see various summary statistics, we could write df.describe and we should get the following information. It gives us the count of the column, the mean of the column, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and the max. And so again, this is really only going to work for numerical columns, which means the season ID will not work for. The integer, which is just player IDs, doesn't really give us anything meaningful. And so if we look at one of the numerical columns like the age, we see that the average age of an NBA player is 27.2. The minimum was 18, and the maximum was 44. If you think this is cool, there are a ton of other statistics on data frames with built-in methods. To name a few, we could do the sum. So this now sums all the columns. We could run the mean method, which gives us the average for each column. We could run df.core, which returns the correlations between columns in a data frame, which can sometimes come in handy. We could run the count, which returns the number of non-null values in each data frame column. And similarly to the describe, we could do the max, which gives us the max for each column, as well as the min, which gives us the min for each column. And then common ones like median, to get the median of each column in our data frame. Get the standard deviation. What you'll notice, what you may have noticed in all of this is returning everything as a series since this is just a single column with the index over here.